Hi friends, in this video we are going to read physics section of Lucent and our topic for today is pressure. Let's read the chapter quickly and then we'll solve questions based on it. Let us begin. Pressure is defined as force acting normally on unit area of the surface. Pressure P is equal to F by A. F is normal force on the surface and A is area of the surface. SI unit of pressure is Newton per meter square, also called Pascal, denoted by P small e. Pressure is a scalar quantity. Some application of the concept of pressure. The bags and suitcases are provided with broad handles so that small pressure is extended on the hand while carrying them. Next, railway tracks are laid on large-sized wooden sleepers so that thrust due to weight of the train is spread over a large areas. And the last point is, pins are made to have pointed ends. This explains why needle is used to burst a gas-filled balloon because needle exerts more pressure. So these were some application of the concept of pressure. Now, next, atmospheric pressure. Atmospheric pressure is that pressure which is exerted by a mercury column of 76 centimeter length at 0 degrees Celsius at 45 degree latitude at the sea level. It is equal to weight of 76 centimeter column of mercury of cross-sectional area 1 centimeter square. Generally, it is measured in bar, and 1 bar is equal to 10 to the power 5 Newton per meter square. Atmospheric pressure 1 atm. Atm is the symbol for atmospheric pressure, is equal to 1.01 bar and is equal to 1.01 into 10 to the power 5 Newton per meter square, which is equal to 760 torr. So friends, you have to remember these facts because in the state PCS and other competitive exams, sometimes they ask these facts. So remember these facts. 1 torr is the pressure exerted by a mercury column of 1 mm length, 1 millimeter length. Now, atmospheric pressure decreases with altitude, that is height from Earth's surface. This is why, first, it is difficult to cook on the mountain, and second, the fountain pen of the passenger leaks in aeroplane at height. Atmospheric pressure is measured by a barometer. With the help of barometer, weather forecast can be made. Sudden fall in barometric reading is the indication of storm. Slow fall in barometric reading is the indication of rain. Slow rise in the barometric reading is the indication of class weather. So atmospheric pressure plays important role in weather prediction. Next is pressure in liquid. Force exerted on unit area of wall or base of the container by the molecules of liquid is the pressure of liquid. The pressure exerted by liquid at depth h below the surface of liquid is given as small p is equal to HdG, where d is the density of liquid, h is the depth, and g is the gravity. Regarding pressure, the following points are worth noting. First, in a static liquid at same horizontal level, pressure is same at all points. Second, pressure at point in a static liquid has same value in all direction. And third, pressure at a point in a liquid is proportional to the depth of the point from the free surface. And the last, pressure at a point in a liquid is proportional to the density of the liquid. So in a static liquid of same horizontal level, pressure is same at all points. Pressure at a point in a static liquid has same value in all directions. And pressure at a point in liquid which is proportional to the depth of the point from the free surface. And pressure at a point in the liquid is proportional to the density of the liquid. Next, we will see Pascal law for pressure of liquid. First, if gravitational attraction is negligible, in equilibrium condition, pressure is same at all points in a liquid. So in an equilibrium condition, pressure will be same at all points in liquid if gravitational attraction is negligible there. Second, if an external pressure is applied to an enclosed fluid. It should be in enclosed fluid. So we'll read it again. If an external pressure is applied to an enclosed fluid, it is transmitted undiminished to every direction. That means it will be transmitted without being diminished to every direction. And its examples are hydraulic lift, hydraulic press, hydraulic brake work on Pascal's law. And they all work on Pascal's law. Next, effect of pressure on melting point and boiling point. The melting point of substances which expands on fusion increases with the increase in pressure. For example, wax. So melting point increases with the increase in pressure, like wax. Next, the melting point of substances which contracts on fusion decreases with the increase in temperature. For example, ice. In the same way, boiling point of all the substances increases with the increase in pressure. So the conclusion is, if we increase or decrease the pressure, the melting point of that substance increases or decreases accordingly. Now let's solve the questions based on it. First, the force divided by area on which it acts is called answer, pressure. Next, what do you understand by the term absolute pressure? Answer, it is the pressure equal to the algebraic sum of atmospheric and gauge pressure. Next, consider the following statements with respect to barometric height. And the options are, sudden rise in the barometric height indicates extremely dry weather. And the second option is, gradually falls in the barometric height indicates that the moisture is increasing. And the answer is both 1 and 2. Both the statements are correct. Next, the atmospheric pressure at sea level is dash atmosphere. Answer is 1. Next, the pressure increases with, and the options are depth has no effect on pressure, none of these. Increasing depth, decreasing depth, or none of these. And the answer is increasing depth. Next, drivers wear special suits in order to protect them from? Answer is high temperature. Next, the pressure exerted by man on the earth is minimum when he, and the options are stands on his feet, sits with folded legs, sleep on the ground, or stand on one foot. The answer is option C, which is sleeps on the ground. So when a man sleeps on the ground, the pressure exerted by man on the earth is minimum because the area is increased and the pressure gets distributed. Next, the gas pressure is caused due to, and the options are gas molecule colliding with each other, gas molecules colliding with the walls of the container, heating of gas molecules, or gas molecules reacting with each other. And the answer is the gas pressure is caused due to option B, gas molecules colliding with the walls of the container. Next, gas molecules colliding with the walls of container. I'm reading the option again. So the next question is, the pressure inside the soap bubble is, and the options are more than atmospheric pressure, less than atmospheric pressure, equal to atmospheric pressure, or half of the atmospheric pressure. And the answer is more than atmospheric pressure. So the pressure inside the soap bubble is more than the atmospheric pressure. And that's all. We have come to the end. Thanks for watching, and if you like the video, please like, share, and subscribe to this channel.